In water treatment process, some chemicals are used as coagulant, disinfection, pH control, and so on. If the dosing amount is not enough, it results in ineffectiveness of chemical. In contrast, if it is too much, it affects the deterioration of facilities and water quality, overspending of cost. Therefore, the proper dosing rate control is crucial. Measuring the chemical dosing rate is calculated as how much chemical is mixed with water to be treated, as this equation. Chemical amount over volume of water. For measuring the necessary data, this video introduces 4 key steps. 1. How to calculate the concentration of chemical solutions. 2. How to measure the chemical dosing amount. 3. How to measure the flow rate. 4. How to find the chemical dosing rate. The first part, how to calculate the concentration of chemical solutions. Prior to dosing and treatment process, the chemical is usually diluted with water to make solution. Let's say the coagulant case in this video. Aluminum sulfate powder is commonly used as coagulant in Bangladesh. When coagulant solution making, for example, that 50 kilograms of sulfate aluminum is put into 1,000 little water. The concentration of the solution is calculated as shown as equation. Concentration equals 50 gram per liter. Those chemical amounts are subjected to operator's standard. Require confirming the rate with operators. In the second part, how to measure the chemical dosing amount. The chemical solution will be dosen at the coagulation point in water treatment plant. Measurement requires stopwatch, bucket, and measuring beaker. To measure how much solution is mixed into water, first, the solution shall be taken with bucket at certain times. Let's set 1 minute in this case, but it can be changed depending on dosing volume and bucket capacity. Here is the coagulant dosing point in water treatment plant. Set the bucket under the dosing pipe to collect solution drops for 1 minute. During the drop collection, be sure not to miss any drops or spill the solution from the bucket, as this may affect the accuracy of the measurements. Also, make sure to keep accurate time. Next, we need to measure the volume of the collected drops by measuring beaker. Place the measuring beaker on a level surface, and when reading the scale, make sure your eyes are at the same height as the liquid surface. Read the measurement at the flat center of the meniscus from eye level. Since the capacity limitation of beakers, measure the maximum amount several times and sum it to find total. Normally, there are some dosing points at the plant, so the amount shall be measured at each point. For example, when 1.4 liters and 1.5 liters of solution was observed from 2 dosing point at 1 minute. It means 2.9 liters solution are dozen. Considering the concentration of solution, 2.9 liters times 50 gram equals 145 gram coagulation powder is mixed at 1 minute. Now the chemical dosing amount is confirmed. However, until the water volume is confirmed, the chemical dosing rate cannot be found. So, next part explains how to measure the flow rate. The flow rate is normally confirmed by flow meter reading at pump. This image shows a water meter, and the smaller dials, the little red needles, are used for precise measurement of smaller water volumes that are less than 1 cubic meter. For example, when it takes 12 seconds to measure 0 to 10 at times 0.1 measures, that means 3,600 over 12 equal 300 cubic meter per hour. As an alternative methodology, pump flow rate can be measured by letting water flow into a tank or reservoir and observing the change in water level together with the cross-sectional area of the water surface. However, since it is difficult to control the fluid precisely, this method is less accurate than using a flow meter and should be treated only as a reference value. It is possible to incorporate this methodology at water treatment plant. Shut off the valve right after filtration so that water can be reserved in the basin. By observing the water level and time, the flow rate can be calculated. Most cases, several pumps are running simultaneously and there are multiple filtration basins at the plant. To make it accurately, those conditions should be considered. As the final part, the chemical dosing rate is going to be found from now on. Let's say there are two same capacity pumps to deliver water from pre-sedimentation pond to treatment plant inlet and two coagulant dosing points. The measured data is shown here. Total water volume to be dozen chemical is 6 lakh liters per hour and chemical dosing amount is 87 lakh milligram per hour. So, as shown at the beginning, the chemical dosing rate equal chemical amount over volume of water, it equal to 14.5 milligram per liter.